Okay, let's recap again. We need to know the definition of the logarithm. We need to know properties of inverses. We need to know our properties of one-to-one functions that I showed you in the last video. We need to know the notation if we use logarithms with base e or base 10. We can see how to convert from exponential form to logarithmic form to solve basic exponential equations. And now we want to convert from logarithmic form to exponential form to solve basic logarithmic equations. So let's take a look. First of all, I see natural log of the argument 10x minus 6. Recall that natural log is log base e. And so this is really log base e of 10x minus 6 equals 3. So by definition, base e to the power 3 is 10x minus 6. So e cubed plus 6 would be 10x. And e cubed plus 6 all divided by 10 would be an appropriate symbolic value for x. And I want you to do something for me though. Every time you have a log equation, remember that you have a domain restriction that you don't have with exponential functions. And that domain restriction is that whatever's inside the logarithm must, as an end result, be positive. So you're going to take this value, sub it in for x, and check. And I'll let you guys go and do that, but I will say that I've already checked it and it does work, and this would be our symbolic answer. And so notice the question actually tells you it's better to present an exact symbolic answer than rounding. So I'm going to leave my guy alone, just like this. Okay, so you should be able to convert from log form to exponential form if you have single logarithm equals a value. Likewise, if you have single log equals single log and the bases are the same, then we can use our one-to-one property of logarithms and say that this is true if and only if x plus 4 and 1 minus x are the same value. Solving for x, since it's linear in x, this is a nice equation. Oops, be careful here. This is negative 3. This would be negative 3/2. Now, just as I said before, it's important that we check against the domain of the original equation. So, the original equation had two separate logarithms. So, you're going to need x plus 4 to be positive and 1 minus x to be positive. So whatever you've gotten for x has to pass both checkpoints. Okay, so we've got negative 1.5 for x. If we check it against x plus 4, we're good. And if we check it with 1 minus x, we're good, because 1 minus negative 3/2 itself would be positive. But again, super important that you check to make sure you don't have extraneous solutions. Alright, so the solution here is actually just simply negative 3/2. Alright, and this will work for you anytime you have, again, single log of a common base equals single log common base over here. And this is if and only if the two arguments are equal. So that's a nice property to use when you can.